Hi all, Mark Schuyler. Today we're going to take a look at imaginary numbers. Perhaps you've studied these in school, but it was long enough ago that you've forgotten a little bit about it, so you wanted to shake the rust off. You've come to the right place. This will be a nice short video. And for those of you who've never studied imaginary numbers, you'll see that they're pretty easy. They're not scary at all. So I have written here on the home slide, I is the imaginary unit, and it's equal to the square root of -1. And that's an impossibility. It's not a real number. That's why we call it an imaginary number. And I'd like to explain why that is. So very briefly, it works like this. When you are taking the square root of any number, let me just show you an example. Let's say we take the square root of 4. What the square root sign is asking us to do is go out and find the number that times itself is equal to 4. And if you want to be really accurate about it, it's not just the number 2 as an answer. Yeah, positive 2 times itself, positive 2 is 4, but -2 times -2 is also 4. So if we want to be really official about it, we could say the answer is ±2. But that is what the square root sign is asking us to do. Let's just take a look at another example of the square root. Okay, so square root of 100. It's saying go out and find the number that times itself is equal to me, 100. And we know that answer is 10, and even -10 times itself is 100. All right, well, look at that negative sign underneath the square root. That's not possible in the real world, because if you are asking what number times itself is equal to -1, you're not going to find a number. If you're thinking it's -1, it's not, because -1 times itself, -1, is +1. And certainly it's not +1, because +1 times +1 is 1. So there's really no answer in the real world to the square root of -1. Hence, we call it the imaginary unit. So I just wanted to make sure the concept was firmly embedded. Now I want to make sure that you understand that the imaginary numbers, it's not enough just to know I. You need to know I squared. You need to know I raised to the third power, I cubed, and you need to know I raised to the fourth power. There's a series of 4 here, a sequence of 4 that's very important. Each one of these has a separate value, and this series of 4 is absolutely critical to understanding imaginary numbers and being able to use them with complex numbers. And remember, a complex number is a mixture of real and imaginary numbers. So we need to have the imaginary part down cold, which is what you're going to be able to say you have it down cold. It's all you need to know for the SAT and ACT after watching this video. So what is I squared? Well, for those of you with a really great memory, you might remember that it's -1. What's I cubed? For those of you with a great memory, you might remember it's -I. What's I to the fourth? It is +1. And you know what? My memory's okay. It's middle of the road. I've never had the greatest memory. It's not been terrible. I found it a little difficult to remember this sequence. It was easy for me to scramble what they are, and believe me, I've worked with enough students, I've seen that the majority of people have the same problem that I do, which is if you walk away from this for a few months, or you're under test pressure, you may forget the sequence. So here's what I propose to do. Instead of relying on our memories, let's really understand why I squared is -1. So if you understand what's going on in the background, you'll really get it. Well, you can think of I squared as I times I. And we know that that's the same as saying the square root of what I is, square root of -1, times the square root of -1. Well, when you multiply 2 square roots together that have the same number underneath them, Let's just take a look at the square root of 10 times the square root of 10. It's the square root of 100. And what's the square root of 100? It's 10. So do you see how you just get the number that's underneath? So what number is underneath these two square roots? -1. That's why I times I squared, is -1. Now, it's easiest to jump down to I to the fourth. Another way of talking about I to the fourth, let me just draw some arrows here, is to say, well, that's the same, following exponent rules, as saying I to the second times I to the second. And we just learned what I to the second is, right? I to the second is -1. And -1 times -1, I'll put little parentheses around these, that's going to be, that's going to be +1. So that's pretty easy to derive the value of I to the fourth if you remember that I to the second is -1. And you'll remember I to the second is -1 if you remember it's just I times I. And what happens when you have the same number underneath two square roots that you're multiplying together? You just get the number underneath. So the one that gives people a lot of trouble, and the one maybe make a little memory effort on, is I to the third. I to the third, let's actually draw a little arrow and give ourselves some space down here. Using the process that we've been using so far, maybe we should break it out that I to the third is the same, using exponent rules, as multiplying I to the first times I to the second. Remember, with exponent rules, when you're multiplying these exponents up here, you're really adding them. So that's where we're getting I to the third from. Well, I to the first is just I, and we know that I to the second, is -1. And when you multiply -1 times anything, times my favorite number, 5, well, -1 times 5 is -5. So I'm going to have -I as an answer here. That is where we get the value of I cubed. It's -I. Now, before we leave this slide, let me just point out something here. I'm going to change colors. I want to point out that I to the first is a true imaginary number, right? Doesn't exist. But I to the second, it's really a real number. I to the second is actually -1. I cubed is back to being purely imaginary again. The answer is -I, and that doesn't exist. It's not real. I to the fourth is back to being a real number. It's 1. Now, I think we're pretty far along. Really, I only have one more goal in this video. It's to make sure that you understand what happens when we continue, when we talk about what's I to the fifth, what's I to the sixth, what's I to the seventh. So let me move on and take a look at the next slide. We could use some new space. I'm going to go back to using white. And very quickly, I'm going to write down our pattern here of I squared, I cubed, I to the fourth. Since we're on a fresh slide, this will already test your memory, right? We'd say this is the square root of -1. We'd say this is, well, square root of -1 times the square root of -1, 1. This is going to be -I, and this one is going to be +1. Sorry, I missed the negative sign up there. So, I to the fifth, what's that going to be? Well, let me write it up here. And I'm going to follow it with I to the sixth, I to the seventh, and I to the eighth. So here's what I want you to realize is I to the fifth is the same as I. Same answer. It's the square root of -1. I to the sixth is the same as I to the second. -1. I to the seventh, -I. I to the eighth is the same as I to the fourth. It's back to +1. So if I were to randomly quiz you and say, hey, John or Mary, what is I to the 12th power? Well, you'd realize that 12 is a multiple of 4. And I to the 4th is 1, I to the 8th is 1, so I to the 12th would also be 1. But if I had asked you, what's I to the 13th? You'd say, well, I'd have to go back to the top of the list now. That I to the 13th would be up here, and it would be equivalent to I or I to the 5th. Do you see? You could always say, well, it's the next one, and so that would be back to the square root of -1. So let me truly throw some random one at you. How about I to the 50th? So what if the SAT or ACT asked you this? Well, I would look for the closest multiple of 4. This is what I would do personally. And the closest multiple of 4 is I to the 48th power. And I know that that is 1 right here. So I to the 49th would be back to the top of the list, the square root of -1. And so I to the 50th would really be the same as I to the 2nd, -1. Right? I can slip in I to the 49th. I'd realize that is going to be the square root of -1. And I to the 50th would be -1. One more random one. See if you can get it. What is I to the 100th? Well, it's a multiple of 4, right? If you divide 100 by 4, it goes in evenly 25 times. It's a multiple of 4. So it is going to be a super easy one. That's just 1. But if it had been I to the 99th, you could back up 1. Right? You'd say, well, that would place me here at where I to the 7th or I to the 3rd is. So it would have to be -I if I had asked for I to the 99th power. That's all you need to know. The concept, and then the series of 4 that keeps repeating in their values over and over. Now it's time for you to move on to my complex numbers video. It will show you how these imaginary numbers work together with real numbers in the real world. So thank you for watching, and may this help you raise your scores.